Requested to do a basic certification overview, kind of give you a little bit of understanding. Try not to make it boring, maybe some things you know, but hopefully we can entertain you and throw in some new stuff to kind of make it challenge. Why do we care? The facility on the left was a milling company, or grain mill, and the one on the right was a fertilizer storage facility. You can see they're no longer there. So the culprit in most cases for the food industry and grain process is static electricity. I spent a lot of time in Louisiana as a specialist up and down the Mississippi River. We built one grain elevator because someone cut a ground on the sidewalk. There's a static discharge, ignited the dust, took down 10 other silos and killed 12 people. Also, we built a refinery. I lived about 20 miles away, shipped my house at 3 o'clock in the morning. It was all because on a flare stack, somebody took a crowbar and a screwdriver and tried to pry a cover. So they introduced something into the burn process that shouldn't have been there. Killed 12 people. The river at that point is about a mile wide. Part of the guard shack is on the other side of the river. A good friend of mine's dad was supposed to go to work. He got food poisoning and never showed up. He would have been in that guard shack. So that's why we care. It's all about engineered products and how you apply the product. So some basic concepts. Today, product protection discussion. We'll talk about the necessary ingredients to have an explosion, a formula. Define the product methods a little bit, talk about class and certification and divisions. The three primary technologies for protection are intrinsically safe, explosion proof, and purge. And we'll do sort of a little bit of deep dive on those three. And you know, the nice thing is every day we come to work, we all make controlled explosions. I probably had several thousand in the year. So what am I talking about? Yes, sir.
Are you having slides that address your facility application?
I've got some pictures of it, but I don't specifically because it was going to be sort of non-commercial.
Oh, okay. Well, what I want to say is, if you're not aware of it, Fairmont Foods has built a large facility out in your area. If you want to let them know what
I've got some pictures. But it's,
okay.
It's 125,000 square foot facility. It's 2.187 football fields, including the end zone, so we can have 4 NFL teams at the same time. But the whole idea is, that's why Catherine is there, that's why Justin is there. We've got engineering support there, we've got manufacturing there, we've got inventory. All of the inventory that was in Ohio is moving down to this facility, so we'll have several $1 million of inventory. If nothing else, you need to come see the high-speed automated retrieval system. Multi-million-dollar investment. This is a $43 million cash investment in the company for the Americans.
Another great thing about our Katy facilities, we moved the manufacturing of our HMI and purge units. They're all made now here in Katy. So if you have short-term demands, or also for rework of older units, we have things come in, they want to replace an HMI or upgrade things. All your support is done now out of Katy, so you don't have to wait for the lag of shipping something to Twinsburg. It's all local. So, and then we offer customers like to come through and do a tour. You can actually see the lines. We make the keyboards, HMIs, bullets. We're about to start doing e-com products locally as well as the solution center in the SEC, where we make the whole solution. So now we have our enclosure lines. We keep in stock inventory, but then we have our own HMIs, purge. So all the equipment is there. And then in the distribution center, we keep inventory stock of a lot of barriers and the other P&F products. So it's nice to have it all in one hub here in Katy.
Again, you don't have to send, some stuff has to go out of country sometimes to be repaired by some of our competitors, and you can drive it and pick it up. We also have cable plans and everything. So we can do a more commercial thing, and anybody is welcome to come with Mike and get it to the facility. Just give me advance notice, we'll make, and it's a good excuse to go to lunch and everything. So Mike can arrange all that. But anyway, I was talking about every day, we drive to work, and coming here, I caused, I don't know, thousands of explosions. What does that mean? Your combustion engine is basically an explosion-proof enclosure. The three elements are there. You need a spark, you need an energy source, and you need oxygen. So that's what happens. And why doesn't the engine blow up? Because it was designed and engineered properly to contain those explosions for a very long period of time. So that's the basic concept here that we deal with in the electrical world. So what's necessary for an explosion? Three elements must be present. We talked about them. Thermoelectrical energy, an oxidizer, which is air, and of course a fuel, a gas, or vapor. Okay. If you eliminate any one of these three components by using protection methods, then the explosion is not possible. There's also a fourth way method, and I got a little example of that. Besides the 3 protection methods, this is sort of an unintentional consequence. I don't recommend that you try this at your facility. But gases and stuff have upper levels, and lower levels. Okay, and how does that equate? If you think back, I grew up in the day when cars had carburetors, and they'd say, "Oh, the car's flooded, it won't start," or "You're not getting any gas." It's so. With that in mind, if the car is flooded or the environment is flooded, it's too rich. You've got too much fuel there. You can't have an explosion. So methane gas atmospheres, anything above about a 15% concentration, you're not going to have an explosion. On the lower limit side, methane gas, anything below 5%, you've got too much air, you're not going to have an explosion. So if you have an atmosphere that's greater than 5% or less than 15%, boom, okay? And this applies to a lot of stuff, get like gasoline. Gasoline's heavier than air. So why is your water heater up off the ground 18 inches? Because the gasoline will never permeate to that level unless you cause it to do something. So you're fine in the gas station until somebody takes the cigarette and throws it down on the ground. Or, they've got their gas tank. I was in the gas station last week and the guy hears this whoosh. He goes, "What was that?" So why don't you put that plastic container on the ground and you won't kill yourself. So, it's just application and big tag hanging on there, please put on the ground, static electricity, that kind of stuff. So there are very many unknowns that can cause accidents. And again, it's all about engineering and application. So the other thing is true of dust. Hershey's trial can cause an explosion, okay? Again, you need to have air and ignition source. You got to have the right amount of dust and concentrations in certain places, and that's what happens. We used to carry a little glass bubble, and we had a heater element in there, and we had oxygen in there, and we'd take the chocolate dust and we'd spray it on the heater element, and poof, it looked like a little spark, okay? So again, static electricity discharge, okay? So, 3 most common equipment protection methods we talked about: prevention. We'll limit the energy in the circuit, which is known as intrinsic safety. So that's one way to do it, is to actually eliminate, take one of the 3 prongs off the triangle and limit the energy in the circuit. The other one is segregation or purge. Okay, so we're going to separate the energy from the other things going on, and I've got some examples of these. And then containment or isolation in this box. It's all bolted and closed up. This is sort of a general purpose location in this box. Okay, so if something happens, we're going to contain it. It will get out of here, but because of the design of the enclosure, you get a refrigerant effect. The bolts are tightened down. So what happens is the burning gas gets cooled. So if the gas exits the enclosure at 399 degrees, and whatever I have in the environment's at 400 degrees, I'm not going to have an explosion because the gas is not hot enough to ignite an event. Okay? So we'll cover these in a little more detail. So defining the protection methods. A little bit of industry terminology. I always feel important when I say I deal with HAZLOC. Okay? Basically, hazardous location. Any classified area where flammable explosive hazard is present or may be present. Ordinary location, self-explanatory. Okay, location with flammable explosive hazard. So that's a non-hazardous location. A certificate or certified means we either have proof of, or a third party has approved the product to be used in a particular environment. In the ATEX world, and this is what Captain kind of manages, when we get all the stuff, we have to declare conformity to a standard. So we list all the standards and say we conform to this, and somebody way up in Captain Fruits signs this thing because it's a legal binding document. Okay, so now we're exposed to a potential event if something's not followed. Okay, in the control drawing, we've got an example of that. So in an IS environment or IS barrier, there's a lot of parameters as to how you can use it, where you can use it, and I've got a picture of the control document here as well. So certification types. You can get an ordinary location. So what does that mean? Okay, you might have an Allen Bradley 509 starter, and you put it in a box. And, it's that enclosure is an ordinary location. What the enclosure does is prevent people from sticking the screwdriver in there and hitting live components and that kind of stuff. So it's more of a, could be an EMA 3R for environmental, but it's just, there was an old ad years ago, Jones is dead. And there was a company that invented the safety switch, but Jones went up and touched the safety switch and got killed. So they decided, hey, we killed Jones. Why don't we put that in a box and maybe the second Mr. Jones won't get hurt. So that's that's kind of a NEMA 1, NEMA 3R application. Again, it's protection from the equipment. Regardless of who is providing the certification is issued only for a product or product family. We're in the process now of getting some of our enclosures, our EJB boxes, we have been involved in that, in order to get Division I certification. So we'll have ATEX, ICX, and Division I on those enclosures. And it's on the EJB family, and it's on the aluminum, and that's got to be done on the stainless steel. So it's a product family that will have the certification. Each product or product family will have a certification, and based on this is how we apply it or use it. You know, you can't take a Zone 1 product into Division I area because it's not approved for that, okay? And again, that's something that I kind of filter when you bring me a quote. If I need high-level expertise, then I go to Cal. Sure, right.
So for the ordinary location, we can do a CE marked enclosure for ordinary location. CE obviously no number, so that would be for Europe. As well, we have a UL and an intersect panel for ordinary locations for 5-way A, as well as the CSA 22.14 for Canada as well. So we have the ordinary locations, industrial control panel certifications, and then on top of that, we for the Hazardous side, for your NFPA 496 for purge, or UL 1203 for explosion proof. These are in addition to the ordinary locations. So your industrial control panel, it is for preventing entry, but also things for proper earthing, wire size, conduit fill. There's a lot of things that go into it to make sure you don't have arc flashing or any kind of hazards to the user, making sure that circuit breakers and things are installed properly. That some can't be in a vertical or horizontal position, and you have overheating and things that cause a hazard. It may not be in a hazardous location, but you can still have a fire or have a hazard to the personnel of the facility.
We just kind of builds on that a little bit. The primary bodies that we use CSA, we use UL, which is the buzzword for everything. European, typically they want a CE mark, and that's the symbol for ATEX, and it's kind of a harmonizing standard. The European Union decided that everything over there had to have a CE mark, so once you got this approval, it could be used in any country without having to do something individually by location. But there still are some challenges because there still are some countries that have their own standards. It's kind of one of these kind of things. And then IECX, which is probably a growing standard, it's probably ATEX on steroids. I guess the United States in very few locations is still a holdout for UL class and division. I mean, ultimately, IECX is probably going to be the standard globally at some point in time. It may not be in my
Fingers crossed, hopefully my lifetime.
Hopefully not.
But no, I wouldn't.
Oh, she wants it, yeah. Personally, I think it's a safer way to do things, but hey.
The Coast Guard's already using it for offshore.
Right.
Rigs on offshore is now ICX.
Yeah, because back then you could do ATEX self-declaration for stuff going in the Gulf of Mexico, and things would happen and the company would go on bankruptcy. So now it's got to be a UL or it's got to be an IECX. And the attractive thing about IECX, if you've got a floating production vessel, you can move that from anywhere in the world. International waters. They don't have to bring it in and take equipment off and put other equipment on it so it can go to a certain country. If it's an ICX, it's pretty much a global standard. Other bodies will accept that certification, so it can go anywhere. It's kind of that harmonizing effect, if you will. So, class, division versus zone. Zone lets you know right away if the hazard is a gas or a dust. Okay, so if I look up here and I look at zone 0, continuous gas. If I look at zone 20, the 20 indicates that it's a dust and water. Okay. On the other side, if I look at class and division, okay, those can represent multiple groups. Okay. So I can have a class 1, division 1, group A, B, C, D, and you can see that dust is all, it's class 2, division 1. So it gets a little confusing on that side. The zone application tells you specifically it's zone 20. Okay, I know it's a dust and water. Okay. Class division requires both bits of information. We talked about it covers dust and gas, and class 1 covers both division 1 and division 2. Okay, so zone is a little more kind of finite focused, if you will. So you kind of get through this guy a little bit. So this kind of indicates division 1, division 2. Division 1 is, basically you've got a hazardous gas or something, hazardous environment all the time. Division 2 is technically, if I've got a storage facility, I've got a bunch of barrels and then I've got a chemical or gasoline or something, the guy with a forklift puts coal in it. It's a temporary situation, so that's considered the division 2. It's not always present. Okay, so the difference between division 1 and division 2. actually under the hood of your car can be a hazardous location because gases can get trapped under there. And you've got some sort of an enclosure, but you've got a great way for an explosion to get out. Okay? And then, of course, you've got non-hazardous areas. So typically an insurance company or a plant that might be self-certified, they'll sit down and argue with an insurance company trying to get as little hazardous as they can. An insurance company wants to have more hazardous as they can. There's a tremendous movement, of course, to try and do everything outside of the hazardous area, and either be non-hazardous or to be Division 2. It's a lot less expensive than equipment in installation. It's a lot easier to maintain. So, in the zone world, they actually take it a little bit further. They've taken Division 1 and broken it down into Zone 0 and Zone 1. Zone 0, gas is always present. Zone 1, it's there a lot of the time. Zone 2 is similar to like Division 2. So that little space, Zone 0, probably rarely happens, okay? So using Zone 1 equipment is theoretically cheaper than using Zone 0. So in Europe or wherever, I mean, I've never run across a Zone 0.
We have a lot of our sensors, our IS sensors will go out into Zone 0, so they're IATA rated. And that's where we see it. You don't never have equipment installed like inside of the tank. It's more of an output from the sensors, so like level sensors, pressure sensors, things like that will have outputs into it.
Yeah, so I mean, typically it's Zone 1, most of the time it's Zone 2, like Division 2. Okay, so same concept, except you get a break here. You don't have to do Zone 0 type stuff. One thing you cannot do is you cannot use Zone 1 equipment in the Division 1 environment. Why? Because Division 1 consists of Zone 0 and Zone 1. So theoretically, if I take, oh, it's Division 1, Zone 1, it's the same thing. No, because Division 1 includes Zone 0 and Zone 1. Okay, so if I take a Zone 1 piece of equipment and put it in Division 1 area, I'm at risk. Okay, because it's not rated yet. Probably won't have a problem, but if something happens and you look at the equipment, hey, Zone 1 and Zone, hey, we've got a problem. So again, that's why Catherine is here to back me up if I do something crazy. So anyway, again, non-hazardous areas around vents and stuff, you know, out of a vent, you're always going to have something present. Division 2 areas, things get more diluted and they're kind of out of the Division 1 or Zone 1 area, it becomes Zone 2. And those are the immediate areas. So groups can be confusing, okay? And you probably know this already, but you know, class and division groups, hazardous type, where you identify subsets of gases. A, B, C, and D are typically gases. E is electrically conductive dust. F is fibers and flames. You know, people making shirts and cotton stuff, and you got flames or open heaters or static discharge. You know, cotton kind of dust kind of floats around here like Hershey's chocolate, and you can have an event. And then G is grain dust. Okay, so typically, you know, class 2 for dust, class 1 for gases. Okay, in the ATEX world, groups are equipment type used to indicate if the device is used for mines or other applications. So the 1 is for mines, which we have nothing to do with, which is a really difficult environment to make equipment to work. And then group 2 is for all others. So that's kind of where we play, more so than not in the ATEX world. IECX marking and CE groups are by hazardous types. So 2C, 2B, 2A are for gases, or EC, 3B, 3A are for dust. And the next chart, I've got another page here. So class versus division. It's a little bit backwards, because in our world, acetylene is a man-made gas. I've been in a plant with acetylene, scared to death, because it was a generator and went too far away, and acetylene is a very volatile gas. Intense explosions, okay? So if you look in the class division world, it's group A, then group B, hydrogen's pretty nasty, group C, D, E, F, and G. In the other world, it's sort of the opposite, okay? It's, you know, in our world, C is okay, sort of, but in their world, 2C is the acetylene. So you got to be careful. You can't say, oh, it's a group C, so I can use a 2C, because it's different, okay? And again, that's what we're good for. So we can help you. Temperature classes, I like this one. A little different in European and United States and North American, just gets silly and goes T1, T2, T2A, 2B. So why is this important? And I used to be a lighting guy, okay? So we'll kind of digress into lighting for a second. A lot of times in a facility, you see an HID fixture kind of thing, and some of them have cone-shaped tops. So that's to get the debris and dust off, because if the dust gets hot, you can have an event. So why is temperature rating important? In a class 1 division 2 fixture, what happens is you've got a fixture and you've got a globe. Well, that globe breathes. So you can get oxygen in there, which you probably have, and you can get a fuel. So what is the ignition point? It's the lamp. That's what the gas gets on the lamp. So it's funny how a couple of different manufacturers can have different T ratings, yet everybody uses the same lamp. I haven't figured that one out yet. So you buy a lamp, it burns at the same temperature. Why is it supposedly cooler than the other one? So that's why it's important. So again, if I take I got a gas that ignites at 200 degrees, which is T3, and I pick a fixture that has a T2D rating on it, am I going to have a problem? You betcha, because I'm 15 degrees too hot. Okay, so the gas gets in, comes in contact with the lamp, it ignites at 200 degrees, the lamp's 215 degrees, I got a hole like that. Okay, and the difference is that in a division 1 world, what they do is it's not the lamp because the fixture is sealed. Okay, so the gases can't get into the glass and touch the light bulb, the lamp, if you will. So then it's skin temperature. Okay, so it allows you to apply the fixture in more places, but it's much more expensive because it's a sealed product. And there's another thing called restricted breathing, which I'm not a fan of. They take a regular division 2 fixture and they plug up the holes with caulking and stuff or silicone. And if somebody takes the silicone out doing a repair or something, you no longer have restricted breathing. So now you have a problem. Okay. So a little bit about T ratings. And the same thing applies to our equipment. Typically in the UL world, if you will, people put a toaster in there, a bunch of other stuff and whatever. Nobody really does any temperature calculations. Okay. If I went to put a bunch of stuff in an IECX enclosure and went to Catherine and said, I'm going to build this, and she ran some calculations and go, all that stuff running at full power is going to burn at 900 degrees. You got a 400 degree environment, she'll kill it. Okay, so I won't do that. So in the IECX world, what we do is we get all the data sheets, we make sure everything has a third-party approval. We run, algorithms and testing to see what that kind of heat that stuff will generate in that box. At full bore, if you will, which may never happen, and it is a safety factor. So we know that if we put this box out there and everything is on, again, it might be 200 degrees surface temperature. So again, you go to T-code, you go, okay, they want a T2D, and I'm T3, I'm good. I'm not going to cause an explosion by turning everything on the box and having a problem. Okay, so any questions on anything? We're kind of moving along here, but it's basic concepts. And again, we can certainly come back and do a deep dive on any of this stuff. So, certifications, marking, and documents. There are many certification bodies that can be used. In the United States, they need to be a NERDL, a national recognized testing lab, a la UL, or Initech, or somebody like that. Okay, I like that word, NERDL. For Canada, they need to be accredited by the SCC, not the SEC, it's SCC, Standards Council of Canada in Canada. Doesn't always have to be CSA. If it's something you approve in Canada, you can use that group for testing and certification. Okay? Who do we commonly use? We use underwriters. UL, the little bug next to it, is anybody familiar with what that means? The CRU-US? No. It's a recognized component. So that means if I had a panel board, and I might have a particular circuit breaker, and it only has a component certification, I really can't apply that by itself. It's part of that UL listed system. So I can take that recognized component, put it at UL approved panel board, and now I have a UL approved system. Okay. So it's really not intended to be used on its own, but part of the system. Okay. That's why the final product is UL listed. Final part of a final product, part of a final product would be a recognized component. Might be a contact, it could be, who knows, could be just about anything. Okay. We use CSA, Intertech. I know Catherine works very closely with those guys. They've been around longer than UL has, right? Probably 130 years or something. Yeah, they were certifying caves and stuff. And then FM or factory mutual is primary electronics. And I think they're kind of delving into the electrical world. So we work with those bodies and a bunch more, and she could stand up here and probably recite 3,000 different. And I'm glad I don't want to do that job.
We have hundreds of certifications. There's some certification things that we built to cover all the different types of panels and protection methods.
The one I like is the grocery basket. The grocery basket cert we set up a list of like 20 million components and said we're going to put this in a box And they said, oh, okay, you can only use 19 million. So she has to take care of all the stuff. But the nice thing is, if you want to Allen Bradley something in here, an Allen Bradley something in here, whatever, she can go ahead and check all that stuff and say, we can build that. So as opposed to, someone going out and getting a product certified, you might go out and get that design with these buttons and this contact, and you might spend 10 grand to get that certified. If you make one change, guess what? It's a different system. You got to go back and get audited and change it, whatever. That's the nice thing about us. She has the power.
That's the one thing I always make sure that, and I tell, especially with engineers, if you get a new project, you have this control panel, it's something you're building, and part of the project is certification. So in your gate safety project or whatever you follow, you have a budget for prototypes for this, for certification cost and time frame. And so that's one thing that's a huge benefit to our customers is that we have already completed the system certifications to cover what you are trying to design. So you don't have to spend 6 months working with a notified body or certified body or UL or whoever you're choosing, Class Div or APEX. We already have it, so we can actually do the approval and certification under ours. So you don't have to pay them $20,000, $30,000 depending on your control panel, plus the 6 months and 500 emails back and forth with your engineer. So it saves you that and gives you more time to work on drawings, prototypes, other things that you would probably rather be doing with certification. So.
Yeah. And we not only we do solutions, we also will sell components. So just be aware. Yes, Mike.
Well, what search are we seeing offshore these days? Is DNV still prevalent on that? Coast Guard, what are you seeing out there?
So offshore is ATEX. You're talking about like on a rig?
Mhm.
It's ICX. So it was ATEX a few years ago was the prevalent. They would allow some class div, but it's like almost 3.5 to 4 years ago. They changed, and now it's ICX is the official certification required for everything on a like Gulf of Mexico offshore rigs. So.
And there's some legacy platforms that of course still here to do class division. So you still.
Yeah, no anything, all ICX.
Yeah, the Coast Guard is. The Coast Guard said no more, no more self-declarations.
Right.
And that's basically what ATEX would let you do. And he said, nah. Somebody would design something, and like I said, they'd go, hey, I'll see you later. I didn't, I'm done. So, okay, all right. So obtaining product certification requires certifications by NERDL certification body. That's number one. Require certified to unclassified general purpose. So if somebody even has this location product, has to have a ordinary location approved. Okay, can't get it, touch, whatever kind of thing. Require certification to classified specific hazardous location standards, class 1, division 1, group B, blah, blah, blah. For hazard certification can be based on class division, zone, or both. So, little magic here. This guy is ETEX, ICX, and UL division 2. So, could be this, or that, or that. We can build a nameplate for whatever application.
What do you do for division 2?
What do we do?
Yeah, I mean.
Well, I mean, the protection for division 2 is sort of, I mean, there isn't, I don't think, in division 2
So
approval.
for Div 2, the box is a type 4X enclosure,
Right.
and it's the components,
Inside.
internal components are either Div 2 rated or terminals and wiring is done to Div 2 wiring methods. And that's for our system cert for Div 2. So we use the UL 12.1201 for non-sensitive connections, as well as the Div 2 components for power supplies. The box for Div 2, there is no class 1
Yeah.
Div 2 box certification.
Right.
It's just a type 4.
I get that.
Yeah.
Because, I mean,
Yeah,
the components must be rated to division 2, or we've got to purchase.
right. There's no EXE for divisions. It's
Right.
just a type 4X. So,
So, but the thing is,
That's why I want to confirm that.
Yeah. it's a question we get all the time.
division 2 enclosure, I can get one. I go, really? Where? I want one. Where are you getting that from? How did they do that?
I hear both flame-proof and explosion-proof, and it seems like they both reside under ATEX, but for different
Right,
areas.
so one is the North American, is explosion-proof, and flame-proof is the
Is
term they
European.
use for ATEX and ICX. They mean essentially the same thing. People use them interchangeably, but the standards, US standards say explosion proof or dust ignition proof, and the ATEX standard, your 679-1 uses flame proof. That's the difference. So.
And the other thing too is, I mean, and we'll get it, you know, some of the box testing requirements are different. We took our IECF box and went to get, you know, whatever, and there's a 4-time safety factor, so we have built up walls, make the box low, you know, that you don't have to 100% test these boxes because there's a 4-time safety factor. They randomly grab one and go, hey, this one's good, so they all must be good. In the IECF world, it's 100% tested, so every box gets a check, if you will. Okay, make sure it has integrity. And we were even drilling and tapping boxes and testing enclosures after we put the glands in. I don't know anybody that does that. So it's really, really, really safe. Okay. So a certificate issued from a certification body is proof that the device or family has met all the needed certifications. The certification body will perform audits, which is what she loves to do.
So much.
When they come, they spend a week and they go, let me see this file, let me see all those pictures, let me just go on the shop floor and stuff like that. I mean, I hear customers, well, I'm gonna become an IEC. I said, okay. After you spend like $500,000 getting all this stuff, and then the changes, you gotta start all over, and the record keeping and all the other stuff. I mean, more power to you. You wanna go down that road, that's fine. I'll sell you the components, but I had an OEM guy. He's my best customer. He did one project. And the amount of money that he spent on all this stuff, I could have built him 7 enclosures, he built one. So now he goes, I'll just let you do it. Certification from one neural SOC body may or may not be recognized by another body. Okay, so an example of a marking, I mean, this is a sensor from our FA division. So you got class and division there. We've got the hybrid standard, which is the AEXNA, the North American standard, which is kind of a combination between UL and you know, an ATEX standard. That's what you see the class 1 zone. I'm going to call out real quick. The Sahara dust is in town, and there's your student. Oh, that's good. Sorry. Oh, sorry. Coffee would just be here.
Went pretty far.
And then you've got an ATEX log on there. So there's a device with what Catherine has stated. It can be used in many environments. That's on there. All the certifications there. We've got paperwork. So that's an example of a multi-certified device. Okay. Starts again. This is an example of a certificate. We won't go in and read all the stuff, but that's kind of what it looks like. There's a certificate of compliance, all the parameters and stuff are on there. All the stuff that we said we would meet and we're approved for is on that certificate. And then a control drawing, like for an IES device, there's all the parameters and applications. Is all on this control group. So it's basically a field guide, if you will, as to how you would apply the device and parameters and things you got to do. So, and all that stuff is available. If I can't get it, you know, Catherine has access to it, so we can supply a complete documentation kit. When you get a solution from us, she creates a very nice binder. Got all the information. If somebody comes in and asks a question, put the binder on your desk, and it is all there. You don't have to do anything.
And the Hazardous website has, you look up any part, you go in, there's several tabs that have documents and then approvals, has all the global approvals product has. In documents, you have all the manuals, safety instructions, control drawings, everything's online. There's other products that you can have some CAD as well. So it's, the website's very nice. They keep it very up to date.
So European Union, CE, we talked about the CE mark. I had a customer who was working on a project. They wanted a circuit board and it didn't have a third-party approval, so they had to go through the process of meeting these directives in order for someone to submit it and get approval. So ATEX is a directive, low voltage is a requirement, reduction of hazardous substances in the board is something that's required, EMC, on and on and on. So in order to comply and get that third-party, that CE mark, in order to be used in an ATEX solution, you've got to meet all this criteria. Cost them a couple $1,000, but it was a huge project, so it was worth it. Company placing into market is responsible for conformance to the required directives. In addition to the CE mark, a declaration of conformity is also required. So we're saying basically, here's all the stuff and we made it, and here's the proof. This is what we said we would do and we do it. DOC indicates all applicable directives and standards used to assess the conformance to essential safety and health requirements. So, documentation required to be maintained by the manufacturer, certification from a third party is one of the requirements. And then for zone 2, we're allowed to do a self-declaration, but more and more people want a third party. They don't trust that you would, oh, it's fine, no problem. They just want to know that somebody else has looked at it and said, look over their shoulder and it's good, they can go and build this. There's a typical marking, and we won't go through that. It's an eye chart. And the thing is, I've got wall charts that explain that. And again, we can come back with Catherine and do a very deep dive into what all the stuff means. You know, a lot of people get confused with the ATEX and IECX markings, which one's which, and that kind of stuff. And we can certainly come back and do that, or we're a phone call away. So that's what this ATEX certificate kind of looks like. It tells you what you're suitable for, temperature ratings, application, number of faults you can take, all that kind of stuff is on the document. And then this is the declaration. And again, somebody way up in Prepland Foods reviewed all the stuff and said, we meet all these requirements. And we guarantee we're going to meet all these requirements. We're never going to deviate from all these requirements. And I'm putting my name on it as Mr. CEO or Mr. whoever. So that's your guarantee that we're doing it. That's your fallback. So list all the relevant directives and standards used to show compliance to all the directive requirements. And the IECX scheme is certification issued from an IECX approved body. We do a lot of ETL and that kind of stuff with those guys. Certification only covers hazardous location. Certificate issued from the certification body is proof that the device meets all requirements. And the certification from one body is generally accepted by all others. And that's the whole idea of taking a ship and sailing around the world. No matter where you go, they pull up your IECX paperwork and everything's, we're good. You go there. So, and that's kind of what the IECX mark looks like. So there's temperature on there, there's the 3C, the groups and stuff like that. You know, there's an operating parameter minus 20, less than equal to whatever, less than equal to 60 degrees C. So all that stuff is contained there. And again, we can come back and do a deep dive on markings. And that's what a IE certificate of conformity looks like. Okay, issued to us. It's managed online. You can pull up all the latest certificates there, and if you can't get to them, Catherine certainly can dig in her toolbox and come up with something. So, going to go back and revisit the primary methods of protection a little deeper, if you will. We talked about intrinsic safety. We talked about containment and an explosion-proof enclosure, and we talked about segregation by using positive pressure, if you will, to keep bad stuff out of the box. So intrinsic safety, basically you've got a device out there, there's no protection, there's no energy limitation in the circuit. A little sparky goes off and boom, you got a problem. So by adding an intrinsically safe barrier, now you limit the energy. It either will blow a fuse or a diode will conduct and it'll take the energy off somewhere on the ground or something like that. Prevent that energy from getting out into the hazardous location. So the barrier resides in the safe area and the other apparatus is in the hazardous location. So it's a system, okay? So the parameters when you pick this stuff out, and I'm not a wonderful IS guy, but I do understand the concept. I'm not sure I can pick one out in all the calculations, but you got to worry about capacitance and inductance, and you got to look at the device, and then you got to worry about cables and how close they are and all of the run and all that kind of stuff. So it's all about energy and energy limitation and dissipation of stuff, temperature.
We have a team of technical support that guys here in Katy, and they are barrier experts. So if you ever need a barrier and you're having issues with matching parameters or you can't find a barrier, let them know and they will find you a barrier. Yeah. That's what they're very good at.
So we have Albino, we have Abby.
You can send Pat an email and he will send you.
I've got cards after, so you can direct stuff to me and I'll make sure we get back to you. But yeah, I mean, they're, tell us about the field device, the parameters and stuff like that. They'll do all the work for you. Come back and say, if you're using this device, this is the barrier you need to use. Not a problem. And our barriers have gotten a lot smaller. Now, these things are 1 inch, now they're like 1/4 inch.
There are-
They're multi-channel, I mean, they've got like paper thin and powered buses and all that kind of stuff.
I have a question. Would a waterproof device be intrinsically safe? Something that would be waterproof like this phone?
They could be,
Wouldn't
But
it
not
but
be?
it's not necessarily right. And waterproof isn't gas-proof. So, and it's more of the electronics and the power, you can still have power inside. And also, so like on a phone, you have to worry about static on the glass, so there's special coatings and things they do on the glass, because you can still have potentially spark. So he's gonna talk about IS phones and things in a minute, so, but there's things you have to do to them to make them.
Just want to make a quick sales pitch for another product instead of yours.
We love that.
Right.
Rockwell Automation has their own barriers. They are Pepperell and Fuchs barriers. We paint ours, instead of the soothing green color of theirs, ours are gray. Look much better in an enclosure. Just to let you know. We don't care. We're good for everybody. We'll sell you a Pepperell Fuchs, we'll sell you a Rockwell. We're the distributor. We don't care. Now, the Rockwell guys in the front, I'm sure they're crying, but we don't care about that. We bought them a sandwich today. They're good.
Well, it's all.
Oh, it's the Rockwell barriers also, so.
The Pepperell Fuchs guys get credit for anything Rockwell said on or not. So I just want to let you know, I mean, we do have not the full complete line that P&F has, but if you notice that the two look pretty much the same, there's a reason why.
Cost the same.
Yeah, they're right there.
We're
I'm sure because
We're
Alan
50%
Rockwell's.
cheaper.
50% cheaper.
They'll add all the marketing.
Because of the volume that Allen Bradley got, they have very, very competitive pricing, so it's rare when these guys will not be.
I'll be, if they touch it, I will address it. Well, I'm working on $1,792 we speak.
So, pros and cons, safer personnel, we don't need a hot work permit to work on it. It's suitable for all areas and classifications. Disadvantages, low energy, low power. Requires front-loaded engineering, so you gotta look at the devices, make sure they're compatible, all these kind of parameters and cabling and capacitance and all that stuff comes into play. It's a pretty involved computation. And then wiring needs to be maintained separately. So there's spacing and dividers and stuff required. Blue wiring usually indicates blue gland, so it's a little bit different wiring scheme. You don't want to mix the two in the enclosure, but you can put them in the same box, but you've got to separate. And we build combination panels all the time. So examples of, it could be a transmitter, thermocouple, temperature device, solenoids. I mean, that's just a wide. So we basically need to know a little bit about the application device you're using, so we can pick the right component to go with. And that's what the engineering guys will do. And we have live online chat. You can go to our website, click on chat, and we have tried other people's chats. They don't answer. We answer our chats. I guarantee we answer our chats.
Don't have any lighting.
We do, but it's European stuff, if you will. Coming from the lighting world, that is getting to be a really ugly, nasty business. You've got a lot of foreign competition. You got a lot of foreign competition showing up with different names on their companies and stuff. It's a brutal business to be in. There are a few guys that are very, very good at the big guys, obviously the Appletons and the Kraus have a position because of the plethora of products they offer in addition to lighting. But there are companies out there who are just doing lighting, which is something I did, and that's a tough place to play. Okay, so, but we do have it, but you're gonna, you look at an ATEX and IE6 fixture, Kraus on VMB probably weighs about 30 pounds. The same equivalent over there probably weighs 150 pounds. I mean, it's a brutal, like, what are you doing? That thing falls on somebody, will kill them. But it's just this mentality of safety, big. So we wouldn't be competitive. So we're not probably ever going to bring.
Indicator lights, I guess.
Oh yeah, pilots and push. Oh, absolutely. Yeah, we do. Not the breadth that these guys have. And I don't have any class of division. Now we can obviously consume and use their stuff, which I enjoy doing. I mean, I grew up in the Allen Bradley world. My first job was to run a modification plant. So I built 2100 centerline motor control centers, 512, 513, Unilocks, I've done the whole gamut. So great product line. Love using it. So anyway, so that's this intrinsically safe apparatus part of it. And there's a device, and again, I talked about input voltages, power consumption, inductance, and that kind of stuff. Those are all calculations that our engineer would use to pick the appropriate barrier based on the parameters that you're using the device with. Okay? And then the intrinsically safe or the associated apparatus, you give us the information about the field device and environment, and our guys will go through, do all these calculations, inductance, capacity, and then give you a recommended barrier, which is something, of course, we do locally in Cape. Flame proof and explosion proof. Designed to contain the explosion. And I'm going to do a little magic trick. That's the best one. Okay. So things that are critical: flame dimensions, thread count. If you have a screw-on cover, that's important. Includes actuators and devices, threaded operators, spotlights, push buttons, and those kind of things. What's installed in the wall of the enclosure? How many openings? You got to be careful. We say you can put 40. You don't want to put 50 holes in the wall. You weaken the wall and have an event. You could fracture the enclosure and have a problem. And then conduit seals and cable glues, and I've got an example of that. We make a cast aluminum box, and then we have welded plate 316 stainless steel. So if you need a Division 1, well, soon, right now, if you need ATEX and ICX, a guy. Soon they have Division 1 welded plate boxes. They're expensive, they're beautiful, but they last forever. Okay? So here's my magic trick. So you see up there, we've got threaded and ground joint, okay? And I've never heard the word interstice before. I'm not sure I've ever seen that, but anyway, this is the presentation. I started with.
It's the flame gap. Yes, that's just a fancy word.
So what is safer? I used to do a demonstration when I worked for another company. If I take this ground joint and I take this screwdriver and put a scratch about the width of your hair in that joint, you hit a flame path. I don't care how much you tighten these screws. You're talking about tremendous amount of pressure in a small box. That flame, when you're going from high pressure to low pressure in that gap, you're getting a refrigerant effect, like your air conditioner. You're taking that hot gas, it cools down as it goes through that compressed joint. And by the time it comes outside, I got a 400-degree gas, and my flame gets out and it's only burning at 399, I'm not going to have a problem. So this is critical. I used to go offshore on platforms, and I'd walk around, and every time I'd see a bolt missing, I'd have to make another. What are you doing? I said, well, I'm the guy who made this stuff. There's a bolt missing. You come back and say, well, he was out here, and he looked at that, and so he thought it was okay. So I stopped going offshore, because I had a notepad full of stuff. I don't think about it. So, and people would do things like put Vaseline on here, or they use copper shield. We got metal particles in here. It's got to be a tight seal. The biggest culprit is they would take this and put it on the deck of a platform, and of course it's rough, so you know tracking and stuff. They pick it up and they drag it across the. I look at it, I said, I don't even want to see that. It'd be a million. Oh, we'll just buff that out, or we'll get some steel wool. Guys, you don't understand. This is thousands of an inch of tolerance. The company I used to work for, we had a machine that cost $2.5 million that would ground these joints and put the covers together, match them. You can't buy a cover from one and put on another one and stuff like that. So here's safety factor. And I'm an old school guy. I'm not an old guy, I'm an old school guy. So what do you think is safer? Okay. This round joint, they might have a loose screw or something. This is your flame path. Okay, that's it. So every bolt has to be tight. There can be no damage between those joints. Or if I have a small GUV with a screw on cover, that's the flame path. So I can take a screw cover box and maybe leave it loose or turn it to, and it's loose. If you take it, you can shake it, and the cover will rattle. Well, the idea is when the explosion happens, the cover will slam shut in the threads, and as the pressure releases, the cover will let loose, and then the cool gases will burn and get outside. So what's safest, if anybody ever asks you, is screw cover. People hate them because I got to go get a leather wrench and pull all that stuff. Well, if you put the STL lubricants, the stuff that are designed, or the HTL, which is the high temperature lubricant, stuff like that, because people put that on a light picture, Vaseline just oozes out of there. Next thing you know, you got aluminum fused to aluminum or stainless steel or something like that. So just a little magic here, just to show you that threaded is a little more safer than this guy. But this is what the industry wants. So that's all I have. Okay. So advantages suitable for high powered equipment, motor starters, circuit breakers, whatever. No certifications required for safe apparatus. Again, it's a general purpose environment inside because of the box itself provides the protection. Large installed base, I mean, they're everywhere. Skills for installation are widely available. I mean, a lot of people know how to work on this equipment if they're with a good electrical contractor or plant people have been trained on how to use and install this stuff. And the maintenance is mechanical, obviously. Disadvantages, large, heavy enclosures, high cost. Conduit seals. How's it going? So if I have a hole here, somebody take this away from me. Okay. Where was it? That one?
Here.
Oh, conduits, there we go. Okay, so we had trouble for doing this for the manufacturer I work for, me and two of the engineers. We put a piece of pipe on one of these boxes, we put some gas in it, we had a spark, kind of like your car, if you will. We stuffed a potato in it. We nailed the police car around the corner, went over the building. The guy came around looking and there was a potato. He goes, y'all see anybody here? Oh, no, we didn't see nothing. So we put tennis balls in there. I could win the Wimbledon. I put a tennis ball and then a piece of pipe and light that thing. I think nobody ever turned that. So anyway, so what I'm basically saying is, if you have a piece of pipe in here, the explosion could get out here, but it's always going to look for the path of least resistance. So is it going to try and get out this joint, or is it going to try and get out of this hole? Guess what? Don't take anything. So I'm going to have flames blasting out of this enclosure. So what the code requires is, when you have a piece of cable, you might have a cable gland, you got to put epoxy in it, okay? The whole idea is to prevent the explosion from coming out of here, but having it come out of here. So a lot of people have never seen what a cord conduit seal, and that's a pretty good job. I got no two wires can touch it, came close, but this is, so explosion hits this, can't get out, and it has to go out the joints. So if you want to pass, I've had this for years. That's my trophy. I was the only one in the class that could two wires touch. So I didn't get anything for it. Okay. So anyway, that's what a conduit seal looks like.
Something to add to that, the most common thing that people mess up on this thing is they got multi-conductor cables, they don't strip the cables, and you got an air gap between the cables going through. That's
No two cables can touch. You can't have a gap anywhere.
gotta be
The
stripped.
worst thing is instrumentation. You deal with a whole bunch of little guys, and they'll do an epoxy as opposed to a forward seal. And it's, you've got, I mean, it's got to be spotted. Otherwise, you have a path of propagation.
The flame pack, so the minimum safe, every gas group has a minimum safe gap. That's how you design something to be explosion proof. Everything's based off of that. Basically, the safe gap is the known distance for each type of gas has one, that at this width and this length, as a fire burns, it will self-extinguish. It cools down as it travels, but it burns up all the oxygen in the space. And if you don't have oxygen, you don't have a fire. So that's how safe gaps are determined. So for every gas group, as you go up in gas group, you get smaller flame gap. So we have a 0.04 flame gap on our EJPs, and that's critical when you torque bolts. So we have torque values, and any explosion proof equipment will have a torque value. Those are important because that's the tested torque value to obtain the minimum safe gap for the gas groups listed on the explosion proof equipment.
Unless I have a screw gun.
Huh?
Unless I have a screw gun. I got
That's-
plenty of flame.
Yeah, so we have screw cutters too.
You got a torque pattern also.
Correct.
That's why it's important. No scratches. Okay, no scratches. Bolts, torque to the right bend, and all bolts in the enclosure. Okay, that's important. That's what makes the system work. Okay, if I take one bolt out, this may not be, it won't seal, and I'm going to have an easy way for that flame to get out and get out hotter than it should, and then we've got a problem. Okay, so suitable for high power equipment. Okay, we talked about that stuff. All right. Keep in mind, overfilling an enclosure could lead to a phenomenon called pressure piling. If you got too much equipment there, you can develop a lot of energy and explosion, and it can do things it's not supposed to. And pressure piling, the explosion will chase unburned gases. That's the whole reason for the conduit seal being within 18 inches of the enclosure. If the explosion happens and it gets out through that conduit system, it will go find something else, and it will blow. We used to put an enclosure, a 10-foot piece of pipe, and a NEMA 3R enclosure on the end. And that enclosure would blow to pieces because that unburned gas would be traveling and go look for something else. Well, that NEMA 3R enclosure couldn't contain the explosion, so it went to pieces. I mean, we had metal shard. It was done behind bulletproof glass. Okay, so if you can imagine somebody standing there, the explosion happening, he's looking over the enclosure, it'll decapitate somebody. It's really nasty. So, may limit who and where entries can be made. In the ATEX IECX world, most electricians have to have competency tests. So you've got to know how to do stuff, install it, they know stuff. UL doesn't really like you to put holes in the field because they're afraid you're going to cut a hole in the top, you're going to have metal filings and stuff and cause issues. So that's a little bit of a challenge. Flame-proof flange integrity is critical. Threaded design is safer. And of course, we already did the magic trick, so I took my thunder a little early. Pressurization, again, segregates the ignition source from the hazardous atmosphere. So the whole idea is if we had gases outside and we have contactors and stuff going on here, and we have oxygen, if that leached into the room, we could have an explosion. So what we're basically doing is turning up the air conditioner real high in here so the pressure is positive as it relates to the outside environment. So the fuel source potentially could not get in the box. So we have a safe environment. Remember I talked about Division 2? The equipment has to be rated. And if it's not, the other option, there are two options, okay? You can put it in this box and purge it, or you can put it in this in an expensive box. And there are trade-offs. You have to have an air supply and all that kind of stuff you buy. If not, then this is the option, okay? So that's basically what purging is. It flushes the enclosure and keeps a positive pressure. Okay, so typical quick example, in a class 1 gas environment, NEMA 4 enclosure, the hazardous gas is removed by purging. Again, positive pressure, so the gas can't get inside, okay? Lower pressure hazardous atmosphere outside cannot penetrate. So if the pressure is higher in the box, then the low pressure can't get in the box. Just straightforward. On dust, a little bit different requirement. Hazardous dust is you have to physically remove the dust. And again, positive pressure, and the dust can't get in the enclosure again because you have positive pressure. So, class 1, the initial state, there's no pressure, equipment is off, okay? Enclosure must be purged 4 times its volume because again, if the enclosure is just sitting there, we said the enclosure can breathe, so you could have some fuel, gas in the enclosure. When you light it off, you could have an explosion. But what we're basically doing is cleaning out the enclosure. We're running 4 cycles of air through there. So by that time, everything's up. We're now safe. After purging is rapid exchange, as it's called. Pressure must be maintained for a safe condition. Now we're good to go. And that's NFPA, National Park Protection. In dust, initial state, no pressure, equipment is off. Inside enclosure must be physically cleaned of all combustible material. Because if there's dust there, you light it off, then the dust could ignite. Okay. The enclosure is sealed and pressure must be maintained for a safe environment. So similar thing. Just the difference is you got to clean up the box. Maybe the only protection method suitable for large equipment. As you get into larger and larger explosion proofs, sometimes this is a better alternative. Because we can purge some huge enclosures, and they're much bigger than you can get with a Division 1 or a box like this. So there are trade-offs. Again, air supply. The enclosures have to be braced because some people purge enclosures that are not rated to. They swell up. Things happen. So you got to use the right equipment again, and that's what Catherine's here for.
Also, when you want an 8-9 things, an IO, the IS touchscreen on a large purge cabinet, stuff that we do control panels and things like that. So.
Yeah. Sometimes that stuff's not ready to be purged, and the glass will break. We've seen it happen before. Protection method suitable for both gas and dust hazards. Provide method to get non-rated equipment. So again, it's either Division 2 rated, or if it's not, it's general purpose equipment for the Division 2 environment. I can purge it, we're good to go. The protection is the purge method, okay? Disadvantage can require a complex installation. If you don't have air, you can use bottle there as well, but you got to go out and change it all the time. Requires other protection methods to operate, and loss of air pressure. In some cases, all you have to do is an alarm for a short period, or you've got to shut down power and shut down the system. Okay, that's one of the advantages of this. You're not going to lose any pressure. Things just happen. So we trade off between purge and explosion proof. So that's it. We went through a lot of basic stuff. Appreciate your attention. If there's anything else we need to do, you have any questions now, You know, we can address whatever you want to do. You're welcome to come to the facility. Just get in touch with Mike, make the arrangements. He'll get with me. We'll set up a time for you guys to come through. And I'm telling you, there's no other facility in the part of the business we're in that looks anything like this. It's absolutely amazing. So, Katy, Texas,
Okay.
behind the Buc-ee's,
99.10.
behind the world's longest car wash.
Yeah.
So it's right at, it's on the way to San Antonio, you pass 99, exit 739. You get off there, Cane Island Parkway, you can't miss it. And if anybody finds the 2,000-pound air conditioner that blew off the building when the tornado hit it first, they'd like to get it back, disappear.
We always say we loved our new building so much, we built it twice.
Right.
We were in the building 1 month today, Harvey hit. Luckily, no one was in the building. A large tornado came through and ripped a few holes in our roof. A few of the 4-ton air conditioner units and the larger ones, several hundred yards away. Luckily, no one was in the building, but we were very lucky. The ASRS system built a new automated warehouse system, but nothing was in it. And then over our office building portion, those were the 2 holes were. So no manufacturing, no inventory, no warehouse, any of that was affected by the flooding that came through the roof. So they patched the holes during the storm to stop the flooding. So we rebuilt the offices and the ASRS and the rest of the building got mopped up. As far as damage goes, we were so lucky that all the manufacturing portion was completely untouched.
What we're saying to cover the next part, one thing we in Hammerhead is Brian and I as automation specialists. With the advent of everyone wanting to be able to look at HMIs on their phones or a tablet, well, whatever Class 1 did 2 or Class 1 did 1 tablets and what is available, that's what we're going to be covering right now. So.
All right, thanks, Pat. So one more time, my name is Justin Olivier. I'm the product manager for the e-com line at Peppermint Foods. So we'll do a little quick history lesson on e-com. E-com was a private German company that was started in 1986. We started off doing measuring calibration equipment, leak calibrators and things like that, but it was all certified for hazardous areas. So we're a lot like Peppermint Foods in the sense that we've always played in that hazardous area space, but where we were different was that we always did mobile equipment. So that's the big difference between the e-com stuff and the P&F stuff, even though we're all one big happy family now. You'll have to forgive me, I'll go back and forth. I was with e-com from 2006 till a couple of years ago, so I still use both names kind of back and forth. So if you kind of look at our history, you'll see a lot of world's first. We did the world's first intrinsically safe cell phone in 1994, I think it was, or something like that. World's first PDA, world's first 4G LTE tablet. So we've always been in this space. It was probably around the time that I started with e-com, around 2006 or so. We really kind of switched the focus from measuring calibration and flashlights, certified for hazardous area. We said, hey, all this mobility stuff is going to kind of be the future. And we played with phones. We've done a couple of PDA type projects before, but that's when we really started focusing on mobile computing and communication. And now both those worlds are all kind of the same. So we're going to play in all the same areas that everything else PNF does. Anywhere there's an explosion risk, that's where you're going to use our products. So that's just kind of our product groups. We won't worry about that too much. The e-com philosophy is kind of everything's about the tablet and phones, and everything else kind of builds around that. So we've got globally EX certified units. We talked about going offshore and needing IEC. On almost all of our equipment, you'll see we'll have ASICs, IEC, and class division, whether that's Div 1 and Zone 1 or Div 2 and Zone 2, all on one device. Again, the big difference with the e-com stuff and the rest of the PNF stuff is it's mobile. So if you're putting a piece of equipment out on a rig and it's IEC, that's great. With IEC, you can move around. We have a lot of customers who are using our equipment. They're maintenance technicians. They're going all over the world. So they might be in the Middle East one day. They might be in Africa the next, then Asia, then they're back here for a month going, repairing equipment all over the place. So we always try to have global certifications on our products there. So thank you for bringing up the phone question earlier, by the way. So this is our Tab X02 series. We did this in cooperation with Samsung. So the question we had earlier was if it's waterproof, is it intrinsically safe? And the answer is not necessarily, but it's a good starting point. So with e-com, what we do with a lot of stuff is we're not going to rebuild the wheel if we don't have to. If there's an existing product out on the market that fits, we'll partner with that manufacturer, the experts, whatever that is, and we'll handle the certification part of it and make sure it's suitable for hazardous areas. So that's what we did with this tablet. And this is the second generation one, but it's based on the Samsung Galaxy Tab Active. So there's the Tab Active 1, the Tab Active 2. The Tab Active was built by Samsung to be an enterprise-grade device. They said there's only so much growth we can have in the consumer market. Us and Apple are going to keep fighting over a few points of market share. If we want to grow, we need to kind of expand our market. So they designed this to be a rugged tablet. It's not in the same range as like some of the tough book stuff that's out there, but it was designed, with drop test and mil spec, and it's waterproof. It's IP67, 68, something like that. So we looked at that and said, that's a great device for our customers. It's a good starting point, but we still had some more work to do. So we go from the rugged tablet to this version, which is the Division 2 Zone 2 version. And if you look at the Samsung device, there's not a whole lot of difference. The size and shape is basically the same. We've got some extra labeling on the top there that kind of identifies it as e-com or PNF. But that also serves to kind of seal all these physical buttons that are on this device a little bit better as well too. And we also have an extra layer of glass to the screen. So even though this was already a rugged device and was already drop tested, we didn't have to do a whole lot of modification. It still looks and feels basically the same as the original device. But we did have to make some changes to be able to get through certification.
There's a particular glue and type of glass, and there's a lot that goes into it. It's not just when you take another slab of glass on top. There's a lot that goes into it to make sure that you don't have any possible emissions or from that.
Yeah, so we have to plasma clean some of the coatings on the glass off before you do glass seals, and it's a very,
intensive process and very expensive.
Yeah, as she mentioned earlier, we're looking
just
at
starting the process here in Katy, so we're starting to work something to bring over some of the manufacturing of some of the tablet things. And I was surprised. I did not realize how much went into it. So I've been certifications for a long time, but it was my first time going into the tablets and phones, and I was surprised at how much.
So right now we're doing all our manufacturing in Germany, the e-com building is there still, but we are looking to move some of that basically as a second production line here in the US, just to kind of help keep up with demand. And getting that set up has been a lot of work. So that's the Division 2 version. When you go to Division 1, this is the exact same device. The hardware in it is exactly the same as what's here, but we've got to do a whole lot more. So this device, we actually use a flame-proof enclosure internally around the tablet, and then what you see out here is kind of a secondary case. There's also some intrinsically safe techniques that we use with the charging circuit and the battery and things like that. The primary concept is flame-proof or explosion-proof, but it does use some IS techniques as well. So this is, again, the exact same device, the difference between Div 1 or Div 2 and Div 1.
See, Justin, the question I would give is, it's not a case around that device. It is a device, because if you take the case off of the device, you're done. This one, you're good.
Can you charge the device in the?
No.
Okay.
It's got to be charged inside the hazardous area. There's, way back in the day, there were some products that you could charge in the hazardous area, but the extra engineering and cost to make that work and get it certified just didn't make it worth it. So we always shoot for a long battery life. We want to make sure you can get through a 10, 12-hour shift, with normal usage, but you can't charge really any of the e-com stuff inside the hazardous area. So as Pat mentioned, we get asked a lot, so you put it in the case, it's like an outer box, right? And that is, every time that happens, our R&D engineers in Germany just start crying. They get really upset. So I promised them that I'll always show this slide. So it's basically just an exploded drawing of all the different components that go in. And we had to, when we created this product, it was the first tablet never been certified for Div 1 Zone 1. We had got a lot of patents, and it took a long time because we had to sit down with all the notified bodies and kind of get stuff approved, because a lot of what we were doing was brand new. Nobody had ever really done it before. So it is much, 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 much more than just a case. And it is a case in some sense, but there's a couple different levels of housing.
What is the cost range of the three?
The standard Samsung device, depending on what version you get, is around like $400 to $600, up to like $700. Div 2 is around $1,500, and you go to Div 1, it's around $3,000. Just rough ballpark. There's some configuration options, but that's just kind of a comparison between the two different generations of device we had. That's another thing that's a little bit different in the mobile world as compared to a barrier or, a box. That stuff's probably going to be there a while. How much have barriers changed in the last 30 years, Pat? They've changed, but it's still,
Yeah, it's consistent.
it's
More
about,
size reduction.
they've gotten smaller.
Multi-channels, yeah. The principle is pretty much.
Yeah, but it's the same basic concept really hasn't changed with barriers. With tablets, phones, all the mobile equipment we do, in the consumer world, Apple, Samsung, all the big guys, they're pitching out a new phone every year. And that really doesn't work in an industrial environment. So that's another difference. When we worked with Samsung on this, we said, hey, look, if you're going to quit supporting this device in 18 months and quit selling it, 2 months after that, it's not going to work, because we need a little bit longer life cycle. So some of the other stuff that Google's doing, excuse me.
So what is the life cycle?
We usually shoot for at least a good 5 years, within support extending beyond that. And so with some of there's a new initiative we'll talk about a little bit later from Google, called Android Enterprise. And part of that is you have to be certified in that program, you have to guarantee security updates for 5 years. So you might not get OS upgrades, it's one letter OS upgrade, guaranteed, but you have to do security updates for 5 years. Some more stuff kind of about the product. I think everybody knows what a tablet is. From an application standpoint, the sky's really the limit. Anything you're doing paper and pen can be easily put into a tablet. So if you've got any kind of inspection report or any kind of maintenance drawings and things like that can be put on the tablet. The tablet really fits pretty good because it does have a little bit larger screen. It's got an 8-inch screen as compared to a 4 or 5-inch screen that we've got on our phone.
Just as an FYI on the Rockwell side, we have both units in the lab. We're both running them on Bin Manager. So you're able to put your HMI 35,000 environmental server side of it. You don't have to install the software, you just stream it directly to the device. That's an option for you guys to use.
Yeah, so you're not tied to a control panel. You can have the information with you while you're out in the field working, as long as you've got an internet connection.
You can Skype with the engineer and show them the problem if you're out in the field. That's a nice one. We actually do that sometimes in the shop and things, to be able to be in a hazard area and video call and then show the engineer, no, this is what I'm looking at. So, because you can't take your iPhone out in the middle of a plant or wherever to show, or take pictures. You can't take the camera out. You have cameras and you can take photos and things, and put them in your recorder to be able to send real time, this is what I'm doing, so.
We'll do that too. So accessories for it, you guys don't care about our configuration codes. From another thing, from an application standpoint, at P&F, we also have a hard modem. So it's a Bluetooth modem. It's certified for Div 1 areas as well. We have a kit with third-party software from a company called ProConsole. You can get the whole kit ready to go. So you've got a hard field device. You have to do all your programming, certification, everything with it right there. So we pre-installed that software. Ecom doesn't do a lot of software, but in certain instances where it fits, we can do custom software loads on the device. This is one option that we are going to start offering pretty much Monday morning. Everything should be ready to go. Where you get the tablet, you get the modem, you get the software all pre-installed. So you can do all your hard device configurations out in the field. This is our new phone. So this one's going to be out later this year. We're shooting for August. Certifications sometimes hold things up, especially when you've got radio certifications that we're trying to get done around the world as well too. We might not hit that August date. This one is Div 1. There's also a Div 2 version of this and just a regular rugged version. So on this guy, yeah, we didn't have the prototypes when we talked about it. On this, all three versions of the phone are the same size. So this is our home device. So with the tablet, we work with Samsung. With this, we looked at it, kind of weighed the pros and cons, and said there's enough advantages to us building this one kind of completely on our own. We're working with a manufacturer who builds cell phones for all the big cell phone companies. As far as that part goes, but as far as the design goes, we're responsible for it. We're responsible for the software. And a lot of that had to do with software updates and things like that as well too, to make sure we had control over those. So the Div 2 version will look just like this, but with an orange label instead of the blue. And they're all going to be, basically the same size. So they're all kind of built in the same chassis. It's still Android. It's an unlocked device. I work with, like T-Mobile, AT&T. We're working with Sprint and some of the other carriers to maybe have a carrier version of that. But in general, they're unlocked. So Android Enterprise recommended to kind of jump into the mobile world a little bit here. Has anybody heard of the Android Enterprise program other than when I mentioned it 5 minutes ago? So what Android Enterprise is basically Google went out when Android first launched. BlackBerry was kind of the dominant corporate phone. Everybody had their BlackBerry. That's what all the IT guys were okay with from a security standpoint. BlackBerry did whatever BlackBerry did and went away, and then it was kind of iPhone. So most corporate IT people said iPhone is more secure, the most secure now. That's the hot phone. That's what all our executives want to carry. That's going to be kind of the approved corporate phone. When Android first launched, it had a bunch of security issues. Android Enterprise, and those have been fixed. Each generation has gotten better and better and better. Android Enterprise is Google saying, okay, look, we need a special program dedicated just to corporate IT environments. And so part of that program is saying, okay, the hardware, not just from a software standpoint, but the hardware has to sandbox all the encryption and decryption that goes on the phone. So there's a separate chip just for encryption and decryption. And then it's software requirements and how everything's sandboxed on the phone, basically to make sure it's safe. The other part of that is compatibility. Big thing with Android is you've got a million different Android manufacturers and everybody kind of has their own little flavor to it. The Android Enterprise program makes sure that all the APIs are kind of standard Google. So all the stuff developers need to work with a phone is all kind of standard. All the programs that corporate IT people are using to manage devices like this, like AirWatch. I think at P&F we still use BlackBerry Work. That's how they manage our mobile devices there. Mobile Iron, SOTI, there's a ton of them. But whatever that little program is, your corporate IT makes you put on your work phone to access their network. Make sure that all those programs have access to everything they need to manage our device properly without having compatibility issues between the different manufacturers. So on the new Smart EX02, it'll be Android Enterprise recommended when that comes out later this year. And along with that, we'll be launching some other stuff called Ecom Digital Services. And the biggest takeaway from that is it's a way to provision devices. So your IT guys or whoever's working, they don't have to get a device, unpack it, do all the install, set up all the IT networks. All that can be configured on our EDS portal on the cloud. And when you get the device, you take it out, you turn it on, all you've got to do is connect to the internet, and all your management software, any applications you're using, all that stuff is installed automatically. Yeah, so we talked about that a little bit before too. The security updates within 90 days of release. So we've got a time limit if we want to be part of this Android Enterprise recommended program. You're going to get security updates within 90 days. You're going to get them for 5 years. The zero-touch enrollment is what we were talking about there from the provisioning standpoint as well too. How much time do we have?
2-3 hours.
Okay. So I'm not going to bore you with the specs on the phone. It's Android. We've upgraded from the first generation phone to the second. Newer processor, more memory, kind of all the usual stuff you see. I can't even read that, so we'll skip it.
And then the cost of these phones.
Again, it's going to depend on the certification level. The Div 1 is going to be 2,200 or so. The Div 2 is a little bit less than that, around 15, I think, somewhere in there. Another thing that's different,
One other question.
yes, sir.
Will the heart modem work with the phone?
Yes, it will. The current phone we have out now, it would work too, so this one's coming out later this year. So theoretically, we should do the heart modem with the phone as well too, just depends on what you want. It seems like it really comes down to screen size, because they're both Android, they're both capable of different things. You want a bigger screen, you've got a tablet. If you want a little bit smaller screen, you've got this. So one of the things that's different about this from a consumer phone, other than, it's a lot heavier, Div 1 certification, is some of the physical buttons that are on it as well. So one thing that people are looking at phones a lot are replacing radios and things like that, and using them for push to talk. So there's third-party software you can do out there that you carry your software. We have a push to talk button built in here, so you can use your cell phone like a walkie-talkie. We've got some customers looking, and it probably won't happen anytime soon. They're saying, our guys are already carrying a radio, they're all carrying tablets and phones now. If we can combine that into one with all the things we're doing on the tablet and phone, it's one less thing for them to carry, it's one less device. So that's all coming. Sorry?
Very spring.
Yeah.
Yeah.
Yeah. The goal is good.
Yes. Yeah, I mean, that's kind of where it started. And that's the problem. We're seeing that a lot in South America is the old Sprint used it was an IDIN network, and all that technology is kind of going away. So all these push talk networks down in South America are about to lose their IDIN network because they can't support the technology. They're all calling us, so we think it's great.
Battery life.
On our previous generation, this was no issue. You get 14, 16 hours, even with fairly strong use. It's going to be in the same ballpark for this one. We're still tweaking hardware and doing this and that. I mean, I'll go a couple days without charging, no problem, if I'm not using it. But it's all going to come down to what radios you've got turned on and how much you do.
Do they have the SP?
Not on the phone, no. So the S Pen's a kind of a Samsung specific deal. There is styluses that work with it. Usually on the phone, but it doesn't seem to work. It does have a glove mode on the touchscreen as well too. So it can be used with gloves. So we've got the push talk button. We've got a programmable multifunction button here. You can use that to like open the camera or sign it to an app. Or if there's an application developer who's writing custom software for your company, for whatever you use to do your operator rounds every day, they can code that button to do whatever they want. That's all open. We can work there too. And then on the top, it has that red button there is a panic button, alarm button. So if you've got anybody who ever has to work in confined spaces or out in remote locations by themselves, you can use third-party applications to do lone worker tracking with these as well. And so the way that would work, I mean, the red button is a panic button. He can hit that on his own anytime without having to dial and look at the screen and do that. He just got to hit that button and it'll make a call. It'll send text messages. It'll send emails. It'll send alerts to all the first responders with, hey, here's, John's location with lat and longitude. Here's a voice call to him on speakerphone already set up. Or it can use all the different sensors in the phone. So little sensors that tell your phone whether to go in the portrait or landscape. So those can all be used to detect falls and things like that as well too. So you can set those systems up to say if the impact's over 4G, I don't know what the real rate would be, but if it's over a 4G impact, it's going to trigger a pre-alarm. And the user's got to say, yes, I'm okay. And if he doesn't, and then whatever amount of time you set, 10 seconds, then it's the same thing, triggers that alarm as well.
Does it only work over the network?
It would need some type of internet connection. So the alarm can still be triggered, but to send out any kind of notification, either over the cellular network, whether it's AT&T or whoever, or a Wi-Fi connection. So it wouldn't need that. So if you're in a really, really remote location with no cell service. Yeah, it could be tough in confined space. You've got to make sure they've got a connection there. And then on the top, there's an audio jack. It's a little hard to see, but you guys can look at it better later. So there's a screw port there as well. So we talked about people wanting to use these for push talk. And this is the new speaker mic we've got coming out. This one's a prototype as well too. But basically that screw port on the top of the phone is there to secure this in. So for a hazardous area, you'd have to plug in before you go into the hazardous area and then make sure it doesn't come out. So we've got that screw there to hold in that accessory, and that'll work. We've got some new headsets and things like that coming out later this year too.
On the tablets, do the SD cords come with them?
You can get it either way.
Okay. Do the SD cords have to be classified or is it basically?
I mean, we have some that we sell. We to a configuration where you can install it as you purchase it, or you can add them later on the Division 2. On the Division 1, the SD card slot is inaccessible. You can't get to it without basically cutting the interior case open. So you need to order an SD card on the Division 1 first as part of production.
Push the phone function with that by cellular.
Yeah, either cellular or Wi-Fi. It needs some type of network connection. It's not the old school radio. We're actually doing a phone, still going over IP. All the accessories for it, I think that's pretty straightforward. Leather cases, cradles. We do have lanyards, tethers. So if you've got worries about devices being dropped, we've got lanyards and things like that, so you can make sure that they don't, for fall protection kind of stuff. This is just another phone. We'll go over this one really quickly. It's Android. It does have a touch screen, but this is for the old school guys, like a paddle screen. Hey, you said it first, though. And it just has a physical keypad as well, too. So we did, does anybody remember the old Nokia cell phone, Plate Snake, that everybody had? So we had a Div 1 Zone 1 version certified of that. And we still have guys send them in for repair because they refuse to get a new phone.
My dad, it's a Nokia, like 2000 Nokia.
Yeah. We still get them in repair, and like, look, you need an upgrade. We can't get parts or replaces or fix the screen anymore. So that's kind of why this phone exists. It is still Android, it still has a touch screen, but the screen's so much smaller, it's like 2.5 inches, that most people are going to go to the smartphone. The one exception is people really like to use this one for push and talk if that's all they're using, because it is a little bit cheaper. So the Ecom Digital Solutions, this all ties back in with Android Enterprise. This stuff is probably more interesting for your IT folks, so we won't spend a lot of time on it, but basically it makes managing the devices easier. It gives you tools to set up the phone, so if you call me up and say, hey, we use this program and we need these Wi-Fi settings, and we want these security measures installed on the phone, we can set up a portal in our online system once it's all up and running, which should be soon. And your IT department can go through and set up exactly how they want the phone. The phone can be shipped directly to you, IT, nobody else ever has to touch it. You turn it on, you connect to Wi-Fi, and everything gets installed the way it's supposed to be. So that's one of the benefits of Ecom now being part of the PNF family, is having resources for things like this. Ecom has grown. We were about 250 employees or so worldwide when we were bought. PNF's obviously much larger. So that's one of the best things for us, is it gave us the resources to develop our own phone and start offering extra services like this. Okay, let me show this one, and we can stop there. So, since Catherine brought this one up earlier, this is another product that's called the Cube 800. Before somebody asks, yes, it's a GoPro. Not really, but it's a certified GoPro. That's the easiest way to think of it. We worked with a Canadian company called Liberstream on this guy. So the neat thing about this guy is that it does have a thermal imager. So you can use the camera on this to do Skype calls. That works just fine. The difference with this and then with the Liberstream software, and of course now that we're on the time limit, it's not going to want to connect right away, is that you can use the Liberstream software. They're the ones who make the camera. We do the certification, they do the software, to connect with experts all over the world. And everybody's looking at whatever the maintenance guy in the field is wearing. So he can have this hard hat mounted, he can have it mounted on a tripod, looking at the equipment he's working on. There's a laser hammer you can turn on once you turn that on, so he knows what he's looking at. And the technician in Singapore can look and say, hey, that wire's hooked up backwards, you need to switch that or change this or do that.
This is really good for like all your NDE guys out there doing inspections on like pipe welding and all the stuff they have to go through, and it's really nice to be able to take footage and video and record.
So now the Cube is connected to the tablet, and I've got the thermal imager mode on, and it has what they call fusion mode. So it's taking the thermal image and the optical image and kind of overlaying those to make it easier to see what you're looking at. So from a troubleshooting perspective, does that make that better? From a troubleshooting perspective, you can do so much with that by having a thermal imager. The camera is going to cost around $4,500 or so when it's out, around $4,500. But if you compare that to, thermal imagers that are just standalone thermal imagers, that's not that bad. The resolution isn't as high as the high-end FLIR and things like that. But just being able to go out and look at an electrical cabinet and see the hot spot, that's probably where the issue is. You can even pick up gas leaks from a valve if they're significant enough. There's so much you can do with a thermal imager, and the fusion mode on this really makes it a neat application.
What is the resolution?
I'd have to look up the spec exactly. I've probably got it in a couple slides, so we can take a look here. But.
Hey, what about that watch?
This one?
Yeah.
So that's another new thing we've got coming out. It's another Samsung product. They pushed us forward with that. It's basically their Galaxy watch. We're doing this is only going to be Div 2 certified. So there's not going to be a Div 1 version of this. You saw the Div 1 tablet, that's a little bit bulky to wear on your wrist. So this will only be Div 2. People are looking at using these really for a lot of lone worker protection systems as well too. Especially if you've got heart rate monitors and things like that in there that you don't have on the phone. They're also looking at these just from an inventory standpoint. There's a customer in the UK, they're doing inspections. They're using, the tap and pay, Apple Pay, Android Pay. You have that same capability with the watch. So they're putting NFC tags on their equipment. They scan that NFC tag and they've got quick kind of pass-fail type inspection.
If you took a thermal image of me with that camera, so we pretty much done?
Yeah, we're it's time limit, so we'll stop.
Well, again, we're excited to be part of Reynolds. Mike, thank you for inviting us. Mike, thanks for getting us here. We're here, we're local. I got business cards, technical support, solutions for your applications. We work very closely with these guys from a value add and application standpoint. Now with your relationship with the bigger company and stuff like that, this is a first class operation. We're happy to be here and be a part of it. So if there's anything we can do at all, reach out to us, we can direct you, we can guide you for tours and stuff like that. Glad to have it. So with that, thank you guys very much for coming. We appreciate it. Thank you.